Thanks, everyone. The presentation today, my presentation, will briefly look at a couple of upcoming wireless technologies and their associated implications on the spectrum regulatory regime. As Brian mentioned before, and most of you know, radio spectrum is a finite resource, and the demand to access it is expected to increase as with all these new technologies. And because of that, we have to look at efficient use and how to allocate the spectrum efficiently if these technologies are to be able to be enabled in the future. And in the past, depending on specific use of a particular service, we have allocated spectrum in a few different ways, and I will briefly look at these in the next couple of slides. If you look at the administrative licensing or radio licensing, as well as the property rights-based management regimes in New Zealand, both of them have been based on an underlying paradigm of exclusive access and also to relatively narrow bands of radio spectrum. We have also allocated spectrum or created general user licenses, also called GULs or public parks. In countries like the US, these bands are called license exempt for comparison, and we are also creating a managed spectrum park towards the end of this year, where technologies would access spectrum on a shared basis. These, however, have to date generally have been for narrow band allocations, with the exception of one GUL that we have created for ultra-wideband communication devices, which is a wideband allocation. However, it sits below the power flow of existing management rights. I could explain more later on if you want more details. And with the new technologies, the sharing of spectrum over a wide range of frequencies is becoming more and more crucial, and that might somewhat challenge the way we have allocated spectrum in the past. And no doubt we'll hear more about those technologies throughout the day. For this presentation, I will only focus on software-defined radio and cognitive radio and their associated implications. The emphasis on the development of future wireless technologies seems to be on innovation and intelligence that allow greater sharing of the spectrum, and of course the potential to provide higher bandwidth services. Smart technologies like cognitive radio or software-defined radio, etc., that allow for greater sharing of the spectrum is obviously of interest to us as the spectrum regulator. For an example, it is expected that wireless devices that can automatically search for unused spectrum and use them will become readily available over time. And these devices are expected to be able to share spectrum with existing users as well. So from a regulatory sense, we have to ask the question, how best to provide access to spectrum for such intelligent technologies or their users when existing incumbents may already have commercial rights over that spectrum. If we consider software-defined radio, briefly, it is a technology that can be used to alter the operating parameters of a radio communications device, such as its maximum output power, frequency range, etc., by making a change under software direction without having to make any changes to its hardware. The cellular industry seems to be the furthest ahead in terms of technology development, apart from the military, of course, with SDR already on offer, especially in their base station infrastructure. And we see that this trend likely to continue with services migrating from 3G to 4G, etc. Another area that SDR is currently being used is intelligent transport systems. For an example, sensors installed on Japanese highways can notify motorists that a car is stalled ahead. And we hear that further developments are underway for more sophisticated systems that could have multiple applications, such as intersection, collision warnings, warning of the approach of an emergency vehicle, etc., which makes use of SDR. So, are there any regulatory implications? A potential area of concern is of compliance with technical and regulatory standards, because the SDRs have the ability to reconfigure their technical parameters. The ability to reconfigure in itself does not mean that it's reaching the standards. It's just that each configuration needs to conform to an appropriate standard. Another problem, an enforcement problem, might be that if there are developers worldwide developing a lot of software separately from hardware, and some of these not conforming to local standards, and most of these software will be downloadable over the internet as well. So this is an area the ministry intends to closely monitor from a compliance perspective. From a spectrum management point of view, there are a couple of approaches that we think are available to provide access for SDRs. First is the licensed approach, where multiple bands are designated for use, and the frequency changes are only limited to those designated bands. This is what is being used by the cellular industry already today. Another option is the creating general user licensed bands for SDR. And so the SDR would operate in specific bands, GUL bands, within the limits and sharing conditions mandated for those bands. We will need to evaluate if there's future demand to create such bands, of course, and we would also like to hear from you, the industry, if you think there are other licensing options that would be more suitable for SDRs. If we look at cognitive radio, which can be described as a radio that can sense and adapt according to its operational environment. And I'm sure there will be other presentations about cognitive radio, so I wouldn't go into a lengthy description. However, a full cognitive radio is assumed to be fully reconfigurable, that can cognitively adapt itself to the needs of its user as well as its operational environment. Although it might be some time before we see this full cognitive radio being commercially deployed, many of today's radio systems exhibit some characteristics of cognitive radio. For an example, wireless LANs scan GUL spectrum for unused channels before commencing operation to avoid interference and also to coexist with similar users and also with radar. The military also uses cognitive intelligence to search for and intercept radiated electromagnetic energy for military advantage, such as for jamming enemy communications. So Bruce probably would have more information on that. I'm not sure he can share them.